5x5.
Okay, great. So good morning or good afternoon, everyone. So I'll try to give you an update of what's happening in the ExoMars program. Let's wait a second for the presentation to appear on the screen.
Barbara, that's the 7071. You needed to open the PowerPoint.
Sorry.
It was not the attachment. Did you download it?
Maybe not.
Do you want me to start sharing? I have it.
Did you download the file, Barbara? Otherwise, I have it.
Have Brandy do it, please.
Brandy, okay. Do you want to share and then I'll watch the chat?
Yep, just a moment.
Okay. And you do the one after too. Thanks.
Appreciate your patience, everybody. We've got 3 people and 16 screens to have to juggle. So we appreciate you just giving us a second.
Okay, are you seeing slides now?
Yeah, looks good. Could I have the next slide, please?
Sure.
So let's start talking about the trace gas orbiter. So the spacecraft is in good shape. All 4 instruments are working well, but we have recently lost one of the 3 channels on the ACS instrument because the cryocooler is no longer able to bring the detector to the right temperature. So this was a channel that we used mainly for, let's say, the general information about the atmosphere, so it doesn't affect our ability to study trace gases. And then the other thing that is important is on 28th of March, because of restrictions to access our operations control center in Germany, we had to put the spacecraft for 2 weeks into some pointing sort of safe configuration, during which we did not acquire any science nor perform any data relay tasks or landed missions. You may have heard, maybe it was mentioned on the first day, that TGO is now being used extensively to transmit data from NASA surface assets. We are handling a bit more than half the traffic at the moment. But luckily, on the 11th of April, we restored normal operations on the spacecraft. So hopefully things are running as they should now, and we should be up to speed with normal data relay and science acquisition. So we have 2 important discovery papers in the pipeline. I expect that one will come out at the end of spring or slightly, well, let's say early summer. And the other one, the paper is being finished but hasn't been submitted yet, so I expect that one would be towards the end of summer. Well, I won't say more than that because otherwise people will get upset. Could I have the next slide, please? So the next slide, this one talks about the ExoMars Rover and surface platform mission, and the first thing that you'll notice is that it now says 2022. On the 12th of March, the directors of ESA and Roscosmos jointly announced that we were not going to be able to make the 2020 launch. In all fairness, it wasn't because of the coronavirus crisis. We have built the spacecraft, the assembly and integration is complete. What we were missing was sufficient time to do the final verification between avionics and software. But the coronavirus problem really hit us hard after that, to the point that had we been in a position in mid-March to still target the 2020 launch, by now it would have been impossible. Our spacecraft is built in several places in Europe and Russia, and so whenever we have to do tests, we need to have people from many countries that converge at one location to witness or take part in the test. And this has been heavily disrupted, at least over the last 1 month. Nevertheless, I want to show you some images of how close we got or where we are at the moment, and explain a bit what we intend to do in the coming months. If I can have the next slide, please. So here you see parts of the assembly line for the rover. On the front right, you see the analytical laboratory drawer with those white things in the front are radiators that will sit at the front of the rover. Behind, where it says ISO 3, you see the glove box train that was used to assemble what we call the ultra-clean zone of the rover, the part that will come into contact with the Mars samples and that is important for the search for biosignatures, or if you like, the chemical analysis of the material. Next slide, please. This thing you see here is what we call the refillable container, and it's the part of the ultra-clean zone in the analytical laboratory that can get filled, emptied, and refilled 10 times with crushed sample material obtained first by the subsurface drill and then crushed with the onboard rock crusher. And then this is moved and presented to the various instruments in the analytical laboratory for analysis. In the next slide, you will see the last picture we took of the inside of the ultra-clean zone before it was sealed. So let's say from the top right, you see those two little cups. Those are the dosers. So the rock crusher, which is not shown here, would be on the top floor of the analytical laboratory, and it dispenses the sample material onto one of those, they look like espresso cups. And they have a revolving sphere below that pays the right amount of sample. And the sample can be dropped either into one of 32 ovens that we have on that carousel you see on the left, or into the refillable container that I showed you just before. Next slide, please. So here you see the analytical laboratory with the three instruments. So MoMA for the organics analysis, the Raman spectrometer, and micrometer, which is the visual plus infrared spectrometer. The ultra clean zone is at the bottom, and you see it here already pressurized positively so that nothing from the outside can get in. The big golden box you see on the top floor, that's an electronics box. And here to the left of that is a rock crusher. Next slide, please. Here you see the flight model of the rover. This picture was taken in Stevenage in the UK. And when we were racing the rover over a metallic platform to test and calibrate the ground-penetrating radar, you see the GPR antennas on the back of the rover are those sort of copper-looking contraptions. And right above that, you see in white the panoramic camera, which is folded backwards. Next slide, please. This is the flight model of the rover for final environmental test. This picture was taken in Airbus Toulouse in France. And here you see the drill in vertical position, which is what we use when we are drilling down. You see on the left that little window, that's where the hand comes out to receive the sample from the drill. And the mast here is raised, and the panoramic camera is actually obscured by the ExoMars logo. Next slide, please. So at the moment, the flight model of a rover is in Tassai in Torino in Italy. It arrived on the 20th of March. It stayed a few days in its container until people could actually come in to unpack it and install it in the ISO 7 clean room. So right now we're in the process of trying to understand what it is that we need to do. There are a couple of things that we would like to fix. So, for example, we need to reinforce the hinges on the solar panels. And for that, we will have to send the solar panels to the UK for that repair. But then we also need to think about lubricants, how they have to be exercised, because we hadn't initially planned to have the rover an extra 2 years on the ground. At the same time, we are conducting a set of reviews to see to what extent we have verified the various requirements that were imposed on the system. And so this will keep us busy all through the summer. Next slide, please. Another thing that is very important, here you see a picture of the bathtub, which is what we call the rover body. On the back side, the back 1/3, so away from the three technicians we see in the picture, we have a service module. And one of the things that we will have to do is we have to condition the battery or possibly replace it because the flight spare is actually newer than the flight model battery. So this may entail some work on the service module. The front part, what the engineers are pointing to, that's the analytical laboratory. and that occupies roughly 2/3 of the volume. And one of the other things we want to do is we would like to do a vacuum bakeout of the rover with the solar panels out to have an opportunity to further deplete the organic background, both in the bathtub and by flushing with ultra pure argon inside the ultra clean zone. It is very important that we be able to maintain the organic background at sufficiently reduced levels so that we can do the search for biosignatures well when we eventually land on Mars. Next slide, please. So here are some pictures of other elements of a spacecraft. On the left, you have the carrier module. That is the element that takes the capsule to Mars. On the right, you see the structural and thermal model. Next slide, please. This is a picture of the actual FM during, well, let's say 3 or 4 months prior to completing assembly. Next slide, please. In this picture, you see the final stages of assembly in Torino before the descent module was sent to Cannes for final test. So on the left picture, you see the surface platform, and then on the right picture, the surface platform is already integrated in the capsule and is upside down. Next slide, please. So that was a happy picture taken at Torino before the spacecraft composite was sent to Cannes. So the spacecraft returned from Cannes to Torino on an Antonov 124 a few days ago, the 8th of April. And it has now joined the rover in the ISO 7 clean room. We managed to complete most of the tests we plan to do in Cannes, but not all. And so right now, the project team is finalizing a statement of work that we go to industry to request a quote for everything that we need to do that is extra with respect to what we had planned to complete to meet the 2020 launch. Next slide, please. Here you see the flight model of the capsule in the environmental test chamber in Cannes. Next slide. And now I want to talk a little bit about the last 5 minutes about something that is important that we are also working on. Could I have the next slide, please? So in this picture, you see an image of Oxyaplanum, the landing site. What you see in red are the clay deposits that constitute, let's say, the well-distributed prime target from a science point of view. There are other targets that we would like to be able to investigate, but one of the important issues that we are able to resolve with this landing site is that at least we have the clays, which are very interesting, distributed pretty much all over the place. So in red background, you see the landing ellipses that we had for the 2020 launch case. And then we're trying to identify suitable trajectory that will bring us more or less to the same place in 2022. An important point to notice is that the areas that you see painted in purple, those correspond to the mafic lava unit, what sometimes is called the capping unit, that is much, much younger than the 4 billion year plus phyllosilicate deposits, and which constitutes both a hazard for landing, for locomotion, and it's also not really interesting for what the objectives of the mission are. So the 2020 landing ellipses managed to avoid most of the capping unit in the oceanoplanum area. And denoted with scenario 5, and with these arrows, you see two possible approaches for, let's say, a hypothetical trajectory that we could have in 2022. Such a case will be good because it's very close to what we had in 2020. Conversely, in green, under scenario 1, you see what the arrival direction and ellipses would be like for this corresponds to a T2 trajectory, which is a longer arc on the 2022 case. This would be pretty terrible from the point of view of science and landing safety. What is not shown here is on the top right part of these green ellipses, there are large dune fields that would constitute a formidable obstacle for rover locomotion. So on the next slide,
Jorge, if you can speak up a little bit or move a little closer to your mic.
okay, is that better?
So a little bit better. I'm hearing you okay, but a few people are reporting just that you're very soft-spoken.
Okay, sorry about that. So on this slide, you see what we call a pork chop diagram. On the ordinates, on the y-axis, you see the transfer duration of the trip to Mars, and at the bottom you see the launch date. Those black bands that you see denote the length of the launch or the duration of the launch window for different possible trajectories. And then look at the green lines. The green lines denote the local mean solar time at the moment of touchdown on Mars. And for us, it's important that we don't land too late in the afternoon, because otherwise the lander would find itself in a relatively energy depleted condition and with not enough sunlight to recharge batteries. Then with the purple line, you see the maximum atmospheric entry speed of the capsule. So we would like to stay within the, let's say, the dark blue or dark purple, I don't know which way you see it, blob. So the next slide, please. So this gives you a summary of where we are with the possible trajectories for the 2022 launch case. At the moment, the one that seems to be most favorable, that means it gives us the longest surface mission prior to the onset of the global dust storm season. Plus it lands at a reasonable local time. Is this scenario 3A that has the green color at the top. The things that we still have to check is it seems that the azimuths of the landing ellipses are close to the ones we had in 2020, but we would like to have a final check on this. And we probably need to put the lander in some sort of low energy mode or possibly add batteries because the touchdown time is 3:30 in the afternoon. So next slide, please. Some of you may have heard that we had some issues with the parachute. So this shows the parachute arrangement we have for the mission. There's a bunch of pilot chutes, but in essence we have two main parachutes. We have a supersonic parachute with a 15-meter diameter that we use for about 20 seconds, and then a very large subsonic parachute with a diameter of 35 meters, under which we hang for a few minutes. And we had drop tests with these parachutes, and they experienced damage. And last year we turned to NASA and JPL for help, and they have been very, very gracious and have really helped us a lot. And the movie I want to show, if you could switch to that, will show you one of the things that came out of the inspection by NASA was that the problems we were having were mainly due to the bags and not so much to the parachute. So JPL has this facility that they adapted for us that allows us to move or shoot the bag with the parachute along the cable line you see on the top. And then we can test the actual extraction of the parachute from the bag. Because the damage that, or the cuts that the parachutes were getting, they were getting from the extraction bag. So this has allowed us to improve the design of the bags, and we conducted many tests at JPL and until the bags and the parachutes were coming out as they should and without damages. The issue we have at the moment is that the final demonstration that the parachutes are working or are qualified for the mission relies on two drops that we have to do from stratospheric balloons. We were planning to do these from a facility in Oregon, but unfortunately the coronavirus crisis has meant that although the parachutes are ready and all the equipment is ready and the balloons are ready, people cannot travel to the US for the parachutes. And at the end of May, the winds change at the launch site, and therefore this means having to wait until the end of September for the drop. So this is a bit of a bummer. We still hope to do the drop tests in Oregon, but most likely the earliest we can do them is the end of September. And this is the end of my presentation on the status of the mission. Thank you so much.
Thank you, Jorge.
Sorry about that. Fighting with my mute button. I apologize. Thanks very much, Jorge. That was really informative. I see we've had a decent number of questions and comments and discussions about what's going on chat. So I'll just go ahead and open up the mic for Serena or Brandy to go through some of those questions.
Yes, will do. There were two questions that came in from Jim Kaufman. One was a question about the wheel diameter relative to the rover body. He noted that it seemed a lot smaller than the U.S. rovers. Jeff Simmons did point out that the ExoMars rover is smaller than the recent NASA rovers, but I wondered if you could comment further on that.
Yes. I refer you to a paper we published in Astrobiology in 2017 that is open access that discusses this. But it's true, the wheels of the ExoMars rover are relatively small, and they are 28 centimeters in diameter, and the ground pressure of a rover is double that of the NASA rover. So naturally, we would be at a higher risk of sinking or slippage than you would have with the NASA rover. And for this reason, we have also implemented the capability to wheel walk in this rover. So whenever we detect excessive slippage, or if we get bogged down somewhere, we can switch to this other locomotion gait in which we use the wheels as legs. And so we're able to walk instead of roll.
Awesome, thank you. The other question from Jim Kaufman pointed out that Perseverance has had some problems associated with higher than expected friction after DHMR, dry heat microbial reduction bakeout of the sample and caching system components that were coated with dry film lubricants. And Ken Farley said that he would speak a little bit about that for 2020. But Jim wondered if you had heard about this issue, and if so, had you looked into possible similar anomalies for ExoMars?
Well, that's an interesting question. I'm pretty sure that we haven't heard about the issue. I have to say that for ExoMars, things were assembled in this ultra clean train, which meant that most of the DHMR was done prior to assembly, as opposed to after. So things were cleaned and then were assembled in an ultra clean environment where people would work from the outside. A few things went through DHMR afterwards, but none that I think had to do with lubricant.
Okay, thank you. And yeah, I guess you'll hear more about it in Ken's presentation. And then Roy Gladden asked, when will the landing date be selected?
The landing date is determined by the trajectory we use. If we stay with this 3A scenario that I showed, the landing date would be the 10th of June, 2023.
Okay, so far those are the questions.
Thank you.
Okay, anyone else have any questions?
Jorge, Jim just sent a follow-on comment. He says that he thought the lube anomalies were noted on components before assembly. I guess Ken can explain this better in his presentation.
Yes, that's very useful. And if we could get some references that I can pass on to my project colleagues, that would be really useful.
Okay. Rather than start a talk early, I would like to open up the floor for other questions, either for today's speakers before their talk, or any of the issues that were brought up in the last 2 days. Does anyone have any questions or comments they want to bring up at this time? Or is everybody just, running to get a cup of coffee?
I love how in Adobe Connect it will show someone is typing and you're just waiting in anticipation. So a few people say it shows that they're typing.
Okay, I see a question from Roger Bork. In view of recent events, some fraction of the populace will be very resistant to bringing back Martian material even a decade from now. Like the concern about RTG flybys, extraordinary measures for containment will be interpreted as an indication of extraordinary threat. technical arguments often are unpersuasive for this group. Does NASA have any plans for psychological ops or something else to deal with this? I'm assuming this is applying to Mars sample return and the public perception of that. Is there anyone on the line that wants to speak to that? Okay, I'm just going to say this is Brandy Carrier. I know that as part of the planning for MSR that's ongoing currently, there are plans to put into action a public outreach plan to kind of handle public perception of this, and then of course all of the containment and break the chain planning that's ongoing. So, Roger, I'm actually going to see if I can follow up a little bit offline on this since there's no one on the line right now that's really working on MSR. So next question from, oh, sorry, Scott, do you want to say something?
Yes, this issue was brought up in the National Academy Study of Planetary Protection Policy. It was published in 2018. It was also touched on in Alan Stern's so-called PPIRB, and it will be addressed to some degree in the new Academy report on planetary protection that comes out on April 24th. So there's material that's being generated by those groups to outline how to address this. Roger's question.
Thanks, Scott. That's really helpful. Now, question from Carol Stoker regarding white papers. The Strategy for Life paper that was listed as the MEPAG paper led by Alfonso Davila, is that the same paper that Alfonso presented yesterday?
Yeah, I don't know if Alfonso is on right now.
I think maybe for you, Eileen, what is this a MEPAG-led white paper authored by Alfonso, or is it a community white paper?
It's a community white paper. Alfonso is the point of contact.
Okay, thank you.
Yep.
I see a comment from John Rummel. The SSB in 1997 to 2009 has twice made recommendations on this issue. He's responding to Roger's issue, Roger's comment. Most important is an open communications posture and responsible adherence to the Space Studies Board recommendation and those of regulatory agencies.
Right, we have about 2 minutes before our next talk begins. I'm going to suggest that if you have a short comment to type in about the meeting format, that you can go ahead and do that. We'll certainly collate those. So I've seen some discussions about this particular format, some advantages. Obviously, there's a lot of possibility for sidebar conversations. One of the disadvantages, there's a lot of possibility for sidebar conversations. I know that my generation and younger are quite used to communicating in this way. Whether that's an issue for anyone, positive or negative, think about that. We'll just give folks a minute to get a cup of coffee, and we'll start right at 12:20 Eastern Time, 9:20 Pacific Time.
Eileen, this is Richard Zurich. I wanted to say to Jorge that we know how very